Um, we want to look at more concepts involving Avogadro's number, using Avogadro's number to solve mole concept or to determine a mole. Now, you see that when we did mole concept concerning molar volume, we said what 1 mole equals to 22.4 dm cube. But this time around, it is different because we want to use it to know the number of particles or molecules in 1 mole. So there are billions or millions of particles in 1 mole and in moles of substance, but Avogadro's is telling us that 1 mole equals what 6.022 times the power 23 particles. That's the Avogadro's number. So the molar volume is still maintained at 22.4 for gases, especially at STP. And STP means what? At 0 degrees Celsius and 1 atm. So that is that. So if you know that you want to know how many number of particles are in 1 mole, then you have to use this formula, this method. Now let's see. Now for gases at STP, 1 mole of gas is what? 20.4 liter or 20.4 dm cube. E.g., 1 mole of 0.2 of oxygen gas is what? 20.4 liter. But which is for solids and liquid, it is a little bit different. But for gases, it is what? 22.4, which depends on the density. Now let's go back to the Avogadro's number. Avogadro's number is telling us that 6.022 times 10 to the power 23 particles is for calculating 1 mole. So 1 mole of any substance is what? 6.022 times to the power 23 particles, atoms, molecules, or ion. That's what the Avogadro's is telling us. Now, for example, look at this one. They said how many molecules are in 1 mole of H2O? How many molecules are is same thing as saying how many particles are in 1 mole of H2O. 1 mole of water equals 6.02 times over 23. We are looking at how many particles in terms of millions are there in 1 mole of water. So that is equals 6.02 times over 23. Now let's see another question. They said how many atoms are in 1 mole of carbon? It's still the same thing. If you are talking about molecules, if you are talking about atoms, talking about particles, then we use the formula. 1 mole of carbon equals to 6.02 times 10 to the power 23 atoms. That is what Avogadro's number is. That's how we apply this formula. Then look at another question. How many molecules in 2 moles of CO2? 2 moles of carbon dioxide equals to 2 times 6.022 times to the power 23, and that's 1.2044 times to the power 24 in molecules, in particles. So that is how many molecules are there in 2 moles of carbon dioxide. Then see this, we have, and they say what? How many atoms are in 0.5 molecules of, this is just one of example of a common JAM question or Y question. How many atoms are in 0.5 molecules of sodium? Since 1 mole equals 6.02 times over 23, then what's the answer for this one? You just divide by 2. And if you divide by 2, you have 3.11 times 10 to the power 23. 3.011 times to the power 23. So the answer there is we are not calculating anything. We are just applying what Avogadro's number to determine how many atoms, how many molecules, how many particles are inside mole of 0.5. So, and that is half of 6.02 times to the power 23. So that is that. Now let's look at some JAM style of combining the molar volume and the Avogadro's number. What is the volume of 1 mole of gas of oxygen at STP? So at STP, we said STP is 22.4 dm cube or 22.4 liter. So the answer there is what? B. Now they said what is the number of particles in 1 mole of water? I'm not calculating. Just use the Avogadro's number. That's if you calculate that 1 mole of water is what? 6.02 times to the power 23. And the one that is a little bit different is they said if 15 grams of sodium carbonate, was used up in an experiment, how many atoms or particles are there in the compound? So this one, they said if 15 grams of sodium carbonate, that's Na2CO3, was used up in an experiment, how many particles or atoms are there in the compound? Then we are given the atomic masses and we are given one Avogadro's number to be 6.02. That's about 23. Now, how do we do that? The first thing here is what? We calculate the molar mass, the mole. Mole equals what? Mass over molar mass. Let us write our parameters. Mass was given as 15 grams. And let us calculate our molar mass. The name of compound is what? Sodium carbonate. That's Na2CO3. That's what? 2. So Na2CO3. So if you are to do that, it means that we are going to be looking at how we are going to get split out the atomic masses. That's so sodium here is 23. That's 2 times 23 plus 12, which is carbon, then plus 3 times 16. You understand? 2 times 23, that's 46, plus 12 plus 3 times 16, that's 100 gram. Here is 106 gram, not 100 gram. So likewise is 15 over 106 equals to 0.1. The first one, then now take it back to mole. 0.1 times 6.02 times 10 over 23, and that's 6.0 times 10 over 22. So that is the answer. So that is how you calculate this one. So what the basic thing here is that if you want to calculate something of that nature, you first calculate the mole at first using the what? Using molar mass. Probably you have a molar mass somewhere, then you calculate the mole. That is what? Mass over what? Molar mass. So if you are given a mass, you calculate the mass. Then if you are given for the compound, you calculate the molar mass. Then you first find the mole. So when you get the mole, you now equate your mole from the question. If you tell you of any number, if the mole is, then now say, well, 1 mole is what? 1 mole will give us what? From the question, we have 1 mole equals to what? 6.02 times 10 to the power what? 20. So it will have a 6.02 times 10 to the power 23. So that is that. So anything you get from here, just times it, just get your mole and you get final answer. So that's how you determine how many particles are there in 1 mole of a substance, or 2 mole of substance, or 3 mole of substance. See you in our next video.